So now we come to putting it all together. What you're looking at here is an asset loaded into Bifrost with textures applied and then output to the Unreal Engine. We've done several of these over the course. This is just probably the most complicated one. But as you can see, this has loaded and you can see those textures have come in and turned on what they need to turn on. But here are the texture files loaded from Bifrost. So this is the beginnings of a bridge. It's not a bridge yet. It's not really anything more than a workflow at this stage. But as you can see, we're able to load texture files through USD and into Bifrost. And that's one thing we can do. We've done other things already, like this. This is not textured, but it is another way to do it. So we've just gone out using the display color here rather than the preview surface. I'm sure that you're all familiar with all of this stuff that we've done. So what this last session's about is really how we get things from Bifrost into the Unreal Engine. We're kind of building a bridge, but it's not really a bridge yet. There's already an existing bridge for USD. It's called LiveLink. It's mainly concerned with things like skeletal animation. That bridge works pretty much on FBX output. What we're trying to do is build in the procedural power of Bifrost. We can bring things across to the Unreal Engine and preserve the proceduralism back in Bifrost. So as you saw in week 3, which is where this is from, I could go in and change the shape of one of those strands that cut the road out of the forest, come back into Unreal, reload the file, and that would have changed. So instead of an FBX system or like LiveLink, which uses bones, skeletal animation, that kind of thing, where you're actually affecting models. So you're loading and exporting a model. What you're doing with USD is you're really directly manipulating the data. Every time you save USD stage on a Bifrost procedural setup, you are directly affecting the USD data that is written in the file, and then Unreal reads it. Some things would need to happen to make this a proper bridge, and the first one would probably be getting rid of this. So you need, whenever you make a change, you need to reload it. Now that's something for Epic to do. That's not something for Bifrost to do yet. And bear in mind, as we talk about this kind of thing, we're going to talk about building a scene for use in an engine, which is what this is, really. We're going to talk about moving between the two programs, which you've seen me do throughout the videos whenever I wanted to show something in Unreal. It's usually at the end of a video somewhere in the game course. This is the game course. Yeah, and I'm going to talk about what isn't supported right now, especially in Unreal. USD is wide and does a lot of things, right? It does texturing and materials and lights and curves and points and animation and all that sort of stuff. As far as Bifrost is concerned, only some of that is supported. Let's have a look at a really basic way you can get things out to Unreal from Bifrost. Now here's the file that creates this. This is the first thing we'll look at. And if you go into the USD output compound like this, let's make ourselves some real estate. And we'll break down what we've done here, because we're getting several things out through this compound, and it's worth taking a good, it's always been there since week 3. It's been there for 7 weeks. You've always been welcome to take a look at it, but let's do a proper breakdown now to just see what's going on, because there's a lot of custom compounds in here that I've built because there are 2 different things going out here. There are the static meshes, which are the land and the lakes. Those are static. They don't do much. They just sit there and be static. Then there's a point instancer, which is what the trees are done. So really quickly, let's run through this. So we've got our input, as you can see. We also have this USD array prep here. And what this is doing before we do anything else is just getting the right crowns on the trees to match the right trunks and then outputting them. It's literally just reordering an array. That's all it's doing. It's probably pretty lazy of me to do it. I could have done it a different way. Then we go into the USD output. So what comes in here is each pair. So the crown of the pine tree, the trunk of the pine tree, the crown of the beech tree, the trunk of the beech tree, the crown of the Dr. Seuss tree, and the trunk of the Dr. Seuss tree. And here's where they get prepared. So this is the pine preparation. Now there's 3 of these, but they all do the same thing. In here, what's happening, all of this here is setting a unique name. That's it, all of it. That's what all of it's doing. So this is trunk. Then I've got a prefix coming in, which is what you put in. So pine, for example. Okay. So this, once it comes out of here, will be pine crown, because that's crown coming in, pine coming in. Then that sets a property, not a geo property, a property on the mesh, or on the object here, which is our tree. This just triangulates, because game engine, we want it to be triangulated. Last in array, if you look at what comes in, trunk comes in first. So this is the last in the array is the crown. Crown coming up here, get a mesh name property set on it, which is, in this case, it's going to be pine crown. Then we update the mesh normals, because it's always good to update the mesh normals. And we do exactly the same thing down here for the trunk. So this is what happens to the crown. This is what happens to the trunk. And so now what we've got now is two objects that have a property on them, which is their name. And they come in here. Crown goes in the top, the trunk goes in the bottom. And this guy is a loop. So what this guy is doing, essentially, is providing the color jitter on everything. So if we just get a USD back, which is a bit bigger, there we go. You can see that within the pine trees, there are a difference in color. That's what this does. So inside of here, again, lots of naming stuff. Color variation does a hue, saturation, and value jitter, puts it out into the display color for that particular object, and this is where we define our USD meshes, right? So this is where they go from being Bifrost meshes to USD meshes. Here's this one. This is the trunk, but you can tell because the color doesn't change, and this is the crown because the color does, and they go in there. And that is basically how we're getting all of those different colors on the trees. You can see the trunk color is coming in, the base color for the crown is coming in, and then the meshes are coming in as well. So all this is doing is applying a color, don't need that, or that. So really that's what this tree prep is doing across all three. More or less, it's just doing it for each different type of tree. And then it's providing an array of USD meshes out. We get the size of those arrays. We're building the probability array for the scatter, so which one has the probability of being chosen. So those are the array sizes coming in, a sequence array, and it's just choosing a random value from the array based on, well, a random object from the array based on what's coming in. And then this one is, if you want random probabilities, you get that one. If you don't want random probabilities, you get this one. This is all point instances stuff right now. That's where we've got up to. And then there's the point instance randomized selection by probability, which I've customized a bit. You can go in there and take a look and see how that works. But essentially, this is generating instance IDs for the trees. This is the terrain mesh coming in. And again, it just comes in here, has a name applied to it, and as defined as a USD mesh. That's all that's happening there. And the same is happening up here for the lake. So that's the two simplest ones. They're just static meshes. So that's the lake static mesh there. Remember, this is where we set our asset name. So you can see it's lake. You can see that's terrain. And these two are the X-forms, the USD X-form prims that are carrying the lake and the terrain. So if we take a look at the USD proxy, which is where you can see all this reflected, as you know, there's the lake. So that one, this guy here, there's the lake, see? If we take a look at what this is just putting the backslash on it. I've learned to do this a better way. But this is the lake, that's that X form, which contains that mesh. All right, so that's going into the children, that's the prep mesh, and what's coming out of there is the lake mesh. Then that gets added to the stage, and out it goes, and the same happens with the terrain. And really the same happens with the point instancer as well. We're using one instancer, there are the points coming in. which come through here, and they're the instance points. And if you take a look out here, we've done most of our hard work in terms of instancing here. So our instance points are coming from here, this bus here, coming up along here. This is the Bifrost version, and then it comes along and then down, and this is the USD version. They are slightly different, and I don't mind that because I can do more with USD than with Bifrost. So this randomized selection by probabilities custom, which outputs instance IDs for the USD, is the same as all of this stuff going on. So that is scattering some trees on these points according to this instance ID. And that there is added to the Xform trees, which is this guy. And if you take a look in here, we've got a point instancer. Inside the point instancer, we have prototype prim. And that's where we have 4 copies of each tree, each with a different color on it. And you can change that. For example, I can take this guy and you see I've got number of color variants is 4. If I change that up to 5, you can see that the Seuss trees now have 5 color variants instead of 4. So it's a nice procedural way of doing things and really one a while to illustrate. At this point, we've got everything added to its own Xform, everything added to the stage. We go out through the node that enables everything, which is save stage. So there's your stage coming in. That's whether you want to save it or not. And this is the file you're saving it to. Also has these things, which we talked about a little bit when we did the flag, where you've got relative paths, default primitive, enable meters per unit is fairly important because that's your size inside of Unreal. And then the up axis also important because Unreal is Z up, Maya is Y up. We can take a look at what we've actually put here. There's the directory that you're going out to. Now we're using a scale here. I don't do that anymore. So in the last 7 weeks, I've started to use, instead of using a scale, which is being set up here, the master scale, that is a USD transform that is being plugged into all 3 of these prims. And that's how you control the scale. I'm not using that anymore because I've been building this bridge as we go. I'll show you what I'm doing instead when we get a bit further on. But this output here encompasses static meshes, which is, a look at, there's our lake static mesh. I'm just calling it a static mesh because that's what Unreal calls it. There's our terrain static mesh, and the static, they don't do anything. They're not an animated mesh. They just sit there. They're static. And our trees, and that's a point instancer. The nice thing about the trees too is if I carve some things out of that instance, if I remove some points from that object, then it's going to carve out, which is how we made the paths. And then out it goes. So we can jump over into Unreal. We can open it up. This one here, we just saved. Open that. It's just going to reopen the same thing pretty much. And if I'm right, we should be able to come into our prototypes here. Oh no, I set it back to 4. So there's our first one. That is our simplest one. That's why we did it in week 3. That's our static meshes and point instancing. How we set them up, how we do color variation on the point instances, things like that. Feel free to open the file, have a look at how it's done. So the next one we did was the animated meshes, New Zealand flag, lovely. And this is where I'm starting to do material binding as well. USD animated mesh. Again, I've made a compound for it. Feel free to make your own. I'm going to show you a range of compounds that I've made in a minute that I'll explain as we go. And I'm also telling you about some of the gotchas I've found as we go through. And I'll do a little section on that as well. But this one, USD animated mesh, we kind of went through how this works. So I've set this up so that I can define the vertex color here. And I can define the vertex opacity here. Vertex opacity is a bit of a gotcha, okay? USD doesn't like to do float 4s for its color. As far as it's concerned, you've got RGB and you've got alpha, and that's all that matters, right? So that's the RGB and that's the alpha, and these are on the vert colors. So these are just vertex colors, which are super important to a game engine. You can take 4 more channels of information in through those colors and use them for things. However, what's really nice is that Unity and Unreal, especially, we're working mainly with Unreal, but Unity as well does this. It's smart enough to know that if the USD has a display opacity on it, then it just reads it as an alpha channel. And that all turns up in Unreal. Everybody's happy. You can mess with it. We've just taken what we've got coming in, which in this case is our animated mesh, and we're turning it into a USD mesh. What we found out and had to be really careful about is that we needed to use frame on because it's an animated mesh, and that up to a time node so that the frame, on frame 0, it looks like that, frame 5, frame 10, that kind of thing. So that basically is just telling the define mesh that it's an animated mesh. Use the frame. So it's basically loading a new mesh from, in this case, a cache, but you can also do it from Bifrost. It's loading a new frame for every frame you change. It's loading a new mesh for every frame you change. That's just me putting a geoscope on it so that we can see things. So if we take a look in here, there's the scope, geo, it's holding the geometry. There's the flag. All good. I have another scope down here called material, which we'll get to in a minute. They're both being added into this transform, which is the flag loop asset, which is coming in. Their name is coming in here. And then we have, as I explained during the lesson, we have the animated stage port feedback compound, which just adds each mesh to the stage per frame over and over and over and over, sets the time code from 0 to the number of frames here. Then we check to see, well, this is just a little bit different. This is the static mesh ability. So if you want to add static meshes in here, now I haven't, but if you wanted to put in a flagpole, you could add a static mesh into this animated mesh and it would also output it for you. And the way it does that is it takes that static mesh array, checks if it's empty, and if the array is empty, it's just going to put straight out the time code. It's going to come out here. But if it's not empty, it's going to add whatever static mesh you've given it, whatever array you've given it, to the stage on that index. Okay, and again, it's going to come out here. This is where we set our metadata. This is the important thing that I found out. You need to set frames per second, or two things will happen. It will default to 24 frames per second, and Unreal will be a lot more unstable because Unreal would really like to know what frame rate this is, please. And you can see here that I've set up just a little bit of help here so that if you don't put in a frame rate, or if it's equal to 0, if you just leave it at 0, then it's going to default to 24. Because even though it defaults to 24, if you don't put this in at all, this will write it to the USD file. At this point, we're checking to see if there's a material, if we're using a material, using a texture. If we're not using a texture, just go straight out. If we are, this is where the material gets bound, and in this case there's the prim, the flag loop, and there's the path. And you can see here that geo corresponds to that, mat corresponds to that. So it's grabbing the prim and it's grabbing the material and it's binding a material to it if you've asked it to. This if statement is the use texture, so as I said, bind a material or not. And then what we have up here is the time coming in, the time that's coming in here, is that equal to your last frame? So have you reached your last frame yet? And then if you have, that's where we save our stage, and out it goes to wherever we want. If you haven't, it's just going to loop round again for the next frame. It's going to do it again for the next frame until such time as that frame is equal to the end frame, and it saves the stage and you're done. So that's just wrapping up all of that into one compound. There's a fair few options in here. And again, all of these compounds were built as I went. So things have changed. Like this one will actually support a material binding, whereas the one I did for the landscape does not. So that's how that one works. And you can see it's carried in the texture. So if we take the actual flag asset, which is all the way down in here, you can come across to your USD stage. There's our geo, there's our flag loop. Inside the flag loop asset is our actual mesh, right? So this is the static mesh, geometry cache. This is the material. So if we look at the material, you can see it's passed through everything. It doesn't need to, but most of them are set to 0. You can go through and turn these off. We don't want it metallic. We don't want any opacity. We don't want any refraction. All of that sort of thing. That's more of a PBR workflow. But you can see it's loaded the base color texture in here as it should. And in Unreal, you can see it's playing at 60 frames per second. So that's pretty much the best way I've worked out to do vertex animations. Some of the gotchas here is that I didn't know you needed to add that, so Unreal was crashing for a very long time. I started using the scale that's actually built into the Save USD stage at this point, rather than setting up a master scale. So what this means is that if you've got some static meshes in here, they'll get scaled by this as well. Well, it's not really a scale, but it's adjusting the size of everything. So obviously this one was built a bit more recently than the forest. Obviously, because this was done in week 9 and the forest was done in week 3, and you get all that kind of, you get it. This also supports the vertex color. So I've actually got a vertex color on this going on through, but at this point it's being overwritten by the texture which is being used in Unreal. However, the information should still be there. Come into the content browser, grab the USD input material and just drop that on there. You can see very slightly, because the gamma is fairly high, you can see that there's a color variation and it goes from bluish to yellowish. Those are the vertex colors. So they come through as well. If I undo that and undo, and then we get our texture back, awesome. So you've still got access to your vertex colors, even though you've brought a texture in through USD. In our case, it's just a color texture and it was just to set it up. So that's point instances, animated meshes, and static meshes. This is where I've started to collect some outputs that I've been building. Most of them have been built from other things. And they're being put into an output module here. So I've tried to break this up, sort of all of the USDs contained. You create a master stage, you then put something into it, but that's very much the compound I just showed you. That's the point instancer. I believe I've got that ready to hook up, and you can see in my output stage here, I've just got object definitions, and you can pop that in there, give it a second to work out its life. Do we have, yeah, have a lighting issue there. There we go. So that's a really simple point instancer. I can disable that by just removing the animated mesh. There you go. So that's just instance cubes, just as a proof of concept. I also have a static mesh set up, which is a very pretty looking torus with some colors on it and some opacity on it. And I'll give you this file to play with. You know, none of these are at any point anywhere near ready to be published or shown, but they're a really good example for you guys. This is just a torus with a color on it and an opacity on it. So one thing I wanted to show you here is that this mesh color here, this is a auto port. And what you can do with an auto port, which is really nice, is you can put in an attribute. So this guy has a point color here. There it is. So all I've done is say, grab point color, and then it's set that up for me. So that's how you can shade by an attribute, just by using a string. So in this case, what this is outputting is an RGBA vertex color on each vertex. So you can, Maya will show you, you can see where it's transparent and where it isn't in the viewport, which is great. And then that's just going out as my 4 colors on my vertex. Point instancer, we just had a look at. Now this one, let's talk about some of the things that Unreal doesn't support right now, as well as one big gotcha, which I'll show you in a minute. Unreal doesn't support USD points, and it doesn't support USD curves. And not entirely sure why. That's an epic thing. Maya, Bifrost, Maya USD, Bifrost USD all support those. That's all very good. It's all great. So what I've done here is built a USD curve output. And the way I'm doing it is, as you can see, there's some credits in here for people. You should do that if you use someone's compounds, by the way. Give them a credit. They probably worked pretty hard on it. But what this is doing is essentially extruding any curves that come in. So let's have a quick look at this. I have 2 outputs. I have USD curve, so that's an actual USD object. And this is a mesh object going out. So we'll plug that in instead. And there's a curve. Let's make that a bit, I've got some controls, so let's make this a bit thicker. And you can see it's a varying sized extrusion on a pretty simple curve, which is what's coming in here. Curve prep, what does that do? Gets the curve in, gets a fractal noise field, sets the size based on that fractal noise field, gets a fractal turbulence field, makes sure that that's all above 0, and sets the color based on that, which is what you're seeing there, and then just outputs the color and outputs the geometry. which then get plugged into, there's the geometry coming in, right? So what this is basically doing is outputting a mesh. Well, this is outputting a curve, but what happens in here is the curve goes in with the attributes on it. In this case, it's point size, which is giving us the thickness, and point color, which is giving us the colors. Inside the USD curve, it's taking that curve here, using a compound I've built, curve to mesh, converting it to a curve, converting it to a mesh, which you then goes into a static mesh, which you saw before. It's the same static mesh node as I used before, which is then going output as our curve to mesh. We've also got a full USD curve set up in here in case you wanted to go out to curves for the day that Unreal Engine starts supporting curves. What's cool is it's also putting in the mesh color and the mesh opacity. In our case, we're not using it. We're only using RGB, not RGBA. It does the same here for the curve. Then that comes out and goes to point instance. So the only thing that you should probably look at here is you've got two output settings here. You've got the axis for an extrusion, normal, binormal, or custom. Oh, that's for the ribbon, sorry. You've got, yeah, and then you've got an extrusion. So it's a tube. You can make it a ribbon and do whatever you need. So if we make it a ribbon, there you go. It goes black, but there's actually the colors are still there. You can change the normal that it extrudes on, like this. You can even extrude on the custom axis, which will do here. You can see that that's leaned over now. So it's just a really quick setup for taking a curve or a strand in Bifrost and turning it into a mesh for USD output. It goes out through there. And we do everything's done in here that we need to do. So this is the most recent version of the thing I've done, where really all the settings you've got on here is, do I want USD on? Do I want to save it? And where do I want to save it to? And then there's your scale. So in this case, it's 1 meter per 1 unit, because that's basically what this. So this comes in quite big into Unreal. Let's grab that, go over to Unreal, and there you can see a little wormy dealy that we built out of a curve. So it's not really a USD curve, but it's a curve to mesh, but it does get it into the engine if you need to know, if you needed to know how. And of course, if you've got strands flapping in the wind, you then plug it in through the animated mesh, and you can get that through as well. All right, last thing about getting things across to the engine. This guy took a fair amount of hacking of nodes to make it work. What I basically did is I pulled apart preview surface node, and using that, some advice from my boss, who is amazing at USD, and the USD API documentation, I managed to add file inputs to various things: albedo, normal, metal, roughness, opacity, and emission. Okay. And I've just renamed that to be PBR preview surface. That goes out to a really normal USD. So here's my assets coming in, input by path, looping through each one and making it a USD static mesh. You guys have seen that already. I'm giving it basically point color with opacity or whatever you want to call it in there. So that's just preparing it. Then that goes into a geoscope, goes into here, geo. Bifrost for now. Let's hide the originals for now. So there's my geometry. And then I've got a second loop in here, which is where the bind material happens. And it's just binding, bit of naming stuff in there again, so that we've got different and unique names. So this is just binding this material, the anvil texture, which is the hacked preview surface I just showed you, to each of those. Now we come to one of the biggest things and one of the biggest gotchas in this, and something I'm still trying to work out in terms of getting USD across to Unreal. If I just let this do its thing, there's the save stage, preview surface test.usda, that's great. So that would have saved. We'll go over to the engine and we will go to our USD stage and we will open. So this guy's a little big right now. If we go back across, meters per unit to 0.01, back over here, file, reload. Yes, it's a lot of setup just to show you something, but it's worth it. Let's focus in on that guy. Now, I don't know if you can see, but it's probably best if we grab something like that and get real close. What's happening there is that the normals, even with a normal map on, are pretty close, but they're wrong. They're just a little bit wrong. And this is the biggest gotcha I've found between Bifrost and Unreal, or actually between Maya USD and Unreal. And everybody I've talked to about it, everybody I've looked at says this has probably got to do with the way that Epic and Unreal import the USD. The way to fix that is you need to open the USDA file. You need to find everywhere that there's primvars normals, and you need to replace it with normals. So if I replace all of that, save this, come back here, and if I reload this guy, suddenly my normals are perfect. So that's a gotcha. That is a bona fide, I'm not quite sure how to fix it, I'm still working on it, gotcha. But other than that, that's pretty much where we've got to for getting Maya assets through Bifrost. Well, not even Maya assets. This is where I've got to for getting a Bifrost graph that does beautiful procedural things. Think the forest. This one's not procedural, it's just binding materials, and I thought I'd show it to you. Think the forest. We can do beautiful procedural things to that forest. We can add a different kind of tree. We can take a kind of tree away. We can put rocks in the lake. We can do all the cool procedural stuff that we'd like to do. We can even, if we wanted to, displace that lake and put waves in it as an animated mesh and output that, which would be a dumb way to do it. I mean, shaders are always better for water, but in terms of possibility, there's lots of possibility you can do there, right? We can do all of that, and we can bring it across to Unreal pretty quickly. Sometimes with assets, when you've got normals like this, yeah, you've got to go in and make a quick change. But you can see this has loaded all of the shaders. There's roughness, there's metallic, there's all kinds of stuff going on in there, which is quite gorgeous. Okay, keep up with it. Next week, we're going to talk about making a tool, like a studio-ready tool in Bifrost that we can take, do things to, out it goes to a studio for artists to use. Because you're technical artists, when you start, that's probably not going to be your job. When you start, your job is probably going to be like every other junior in the world, where you start small and get bigger. But as you get more and more experienced in tech artistry, you will find yourself making tools for people. As I'm sure you know, because your final project involves making a studio-ready tool. What I will show you next week is how to make those tools in Bifrost, but access them in Maya. So anyway, I hope this has been enjoyable. This is the end of the 2 USD lessons. From here, there are lots of places you can go, like the Bifrost Discord, to get help. Just ask, we'll help you. All of the USD documentation online. I built this by reading the USD API, which gave me a hell of a headache, but it worked. All of that kind of thing. So yeah, hope it's been enjoyable. Hope you've had some nice, shiny Unreal time and you're playing with stuff. And we'll see you next week.